First of all, I'm trying to build an AI and machine learning model to predict this disease, the diabetes. So that's why you see here it's diabetes prediction. So why a brief introduction of this disease, the WHO reported that over 1.6 million people die due to this disease every year. So this disease, how does this disease come about? It just comes about when the glucose or blood sugar levels in the body are very high and the body can't just manage these blood sugars. Yeah. So according to health experts, diabetes occurs when the human body's gland called the pancreas cannot produce enough insulin, and that's diabetes type 1. And then if the produced insulin cannot be used by the cells of the body, that's diabetes type 2. Yes, so why this disease? This disease is just because it's increasing, the growing. This disease is just growing so fast due to our poor health lifestyles. You know, we consume a lot of sugars, you go and this, you eat that. A very big percentage of the food we eat, it contains sugars. So as we consume a lot of sugars, the sugars in the body are accumulating. So the more they continuously accumulate and the body can't handle or can't manage this, then this will just develop, this complication will just come about, the diabetes mellitus. Yeah. So the type of data set we're going to use in these projects, and this same data set is the same we are going to use to train and to test and train our model. Yes. So this data set is called the PIMA Indians data set. It's this data set majorly contains information about females with some attributes that we require. Yeah? This data set, it contains, or it consists of glucose levels, insulin, the age of the person, the body mass index or the BMI, the diabetes pedigree function, and many more. So you can also find this data set at Kaggle in the link provided here. Yes, so this is the link. You can just follow the link and then you'll be able to get this data set. Yeah. So factors considered while choosing this data set. First of all, it has a number of attributes which I will require to train and test my model. And part of these, which include maybe the pregnancies, the body mass index, the insulin levels, the age, the blood pressure, the skin thickness, glucose. It also consists of the outcome. The outcome attribute this is just the dependent variable, as we shall see in supervised learning. The dependent variable obviously must be depending on some independent variables. So the outcome here is the dependent variable. It consists of only two values, 0 and 1, where the 0 just shows that that person is non-diabetic and the 1 shows that person is diabetic. Yeah. Then the rest of the attributes in this data set are, those ones are independent variables. Yes. So part of the selected features, by the end of this project, we shall be having an app, something related to an app or a website or what, where you can be able to feed in your information related to the glucose levels, the body mass index, the insulin levels, the age, and maybe some other fields that will be required to be filled. And then this model shall be able to predict and tell you that, you know what, you have diabetes or you don't have. Yeah. So let's first discuss a little bit about this Bayesian theorem. You know, This Bayesian theorem, like you can see here, the Bayes theorem is given by an English statistician. Wow, this word here, statistician, philosopher, and that this guy, the guy who invented this, was called Thomas Bayes in the 17th century. You know, this guy, the Bayes writes their thoughts in decision theory, which is extensively used in important mathematics concepts such as probability. Yes, in case you've ever attended to the probability classes, you know what Bayes is. You know, this is in computer science. In case you've ever attended to the probability class, you know what Bayes is. Yeah. So this same theorem here is also widely used in machine learning, where you need to predict classes precisely and accurately. An important concept of Bayes theorem. This is by the theorem. Okay, the theorem is just named as Bayes method or Bayesian method, or the Bayesian theorem is used to calculate the condition of probability. You know, even these predictions, we deal with a number of probabilities that maybe this will happen or this will not happen. We deal with probabilities, and these are conditional probabilities. Yes, so this Bayesian theorem, it just helps us to determine the probability that an event will occur based on random knowledge, some knowledge that we have. Yeah, so it's just used to calculate the probability of an event occurring based on the fact that there's some other event that has already occurred. Yes, so like you can read through here. But basically, that's what the Bayesian theorem is all about. I just want this video to be real quick. Yeah. So we come to naive Bayes. So since we know about the Bayesian theorem, a simplified version of Bayesian theorem, this is the naive Bayes. Reason being, this naive Bayes just reduces the number of computations that are done in Bayesian theorem, and then these computations are reduced. The series are reduced. The series, all the steps that you have to follow in Bayesian theorem or Bayesian method. In naive Bayes, these are reduced. So that's why you said this is a simplified version of Bayes theorem, which is also used to reduce the computation time and average cost of projects. Which projects are we talking about here? These are the machine learning projects, like the one I'm working on. So this naive Bayes theorem is also a supervised learning algorithm, which is based on Bayes theorem and is used to solve classification problems. So like here you can see, this is majorly used in machine learning models for quick predictions. It is a probabilistic classifier that means that it predicts on the basis of probability an object. Some popular naive Bayes algorithms are like spam filtration for emails, maybe the sentiment analysis, and classifying articles. Yeah, those are some of the areas where you can use this. Where this is highly recommended. But in this project that I'm working on, that this diabetes prediction, we shall much more use the support vector machine and maybe the logistic regression. But we shall also try to test the other algorithms. So we come to the Bayesian networks. Obviously, as we hear the word networks. This network falls under a category of probabilistic graphical modeling technique that is used to compute uncertainties using the concept of probability. All these are based on probability. So this is just represented using a directed acyclic graph or a DAG. Unlike any other graph, this graph just contains a system. This contains a set of nodes and links where the links just denote the relationships between the nodes. Like you can see in this diagram here, we have node 1, 2, 3, and 4, and we have these are the links. Yes, so these are just the nodes, and then these are the links. So the probability of a random variable is dependent on his parents, and therefore we can formulate this Bayesian network as this formula here, as you can see. Remember, we're just following probability, and this is all model. This directed acyclic graph models the uncertainty of an event occurring based on the condition probability distribution of each random variable. So that's why we say that the probability of a random variable is dependent on its parent. It is depending on something else that might have occurred, and then, yeah. So these are some of the differences between the Bayesian theorem and naive Bayes. Like we all know, yeah. You need to know that the distinction between Bayes and assumes the condition, this just assumes the conditional independence where Bayes' theorem does not. So what does this statement mean? Naive Bayes just, okay, for it, it assumes conditional independence. There is independency in this, like, you know, if you know about probability, there is what we call independent events, and then there are those which are dependent. Then this naive Bayes assumes conditional independence, whereas Bayes' theorem or the Bayesian theorem does not. This means that the relationship between all the input features are independent. Yes, so maybe not a great assumption, but this is why this algorithm is majorly called naive, because it just sounds like naive. Basically, that's the difference between naive. Just assumes conditional independence, whereas this Bayes theorem does not. Yeah. So the difference between this is now naive Bayes and then Bayesian networks. Bayesian network just models the relationship between features in a very general way. If you know that these relationships all have enough data to derive them, then it may be appropriate to use this network. Like we saw, this Bayesian network just consists of nodes and then links. The links are the ones that denote the relationships between the nodes. Like we saw in the previous diagrams, where this node 3 is dependent on nodes 1 and 2, and then node 4 is dependent on node 3, like that. Yes, so these are some of the references. You can get the data set